Hey Adit, can I ask you something? I'm trying to understand the coloring problem in graph theory, but it's a bit confusing.
Of course, Dennis. The coloring problem is a classic topic in graph theory. Basically, it's about assigning colors to the vertices of a graph so that no two connected vertices share the same color.
Oh, I see. So it's like coloring the nodes? But what's the main goal?
Exactly. The goal is to use the smallest number of colors possible. That minimum number of colors needed to color a graph properly is called the chromatic number.
Interesting. So for simple graphs, maybe two colors are enough?
Right. For example, bipartite graphs can always be colored using just two colors. But as graphs become more complex, we might need 3, 4, or even more colors.
Can you give me an example?
Sure. Take a triangle graph, a cycle with 3 vertices. Each vertex is connected to the other 2, so you need 3 different colors. 2 wouldn't be enough.
Makes sense. But what if we just use a lot of colors? Wouldn't that make it easier?
Yes, but in real-world problems, we often want to minimize the number of colors. For example, when scheduling exams, assigning radio frequencies, or optimizing resources in computing. Fewer colors mean more efficient use of resources.
Oh, kind of like making an exam schedule. So classes that share students don't have exams at the same time?
Exactly. That's a real-life application of graph coloring. Each course is a vertex, and if 2 courses share students, there's an edge between them. The colors represent time slots.
That's really cool. But how do we find the minimum number of colors needed?
That's the tricky part. Finding the chromatic number for any given graph is actually an NP-complete problem. But there are algorithms and heuristics that can help estimate or approximate it.
Wow, the more I learn, the more interesting it gets. Thanks a lot, Adit. Your explanation really helps.
That's some explanation that I can give. Hopefully you don't get dizzy because it's too much.
You are not wrong, but the material is indeed rather complicated. Thanks, you have explained at length.
Anytime, Dennis. Once you get the hang of the coloring problem, you can explore things like edge coloring or list coloring too. But that's a topic for another day.